It's circuit time! Yes, we're going to look at solving some basic circuits. So here you go. Super basic circuit, like entry level 0.5. Your goal, determine the voltage drop and the current through each resistor in the circuit shown below. Alright, so take your time, crunch the numbers, get some answers, and I'll see how you did. Alright, so pause the video, do some work on it, and when you're ready to get a hint or a clue or you think you're done, then start it back up. Alright, I'm not going to tell you the answers, but I am going to tell you the very first step. So the very first step is you need to check to see if you have the equivalent resistance of the entire circuit. There's my brain. So you got to find the equivalent resistance of the entire circuit, and to do that, you got to figure out what type of relationship these resistors have to each other. So these resistors are all in series, because if I was to do trace my path, there's only one option. It never breaks, never splits up. There's only one path. So since each electron will travel through all three of these are all in series. So to determine the total resistance in series, you add them all up. So we got a 5 plus a 6 plus a 7. We get 18 as my equivalent resistance. That is step 1. So I'll just write 18 as my equivalent resistance. So that's like what the battery feels. All right. The next step is to use my friend V equals IR. So once you've got that, start plugging and chugging. See what we get. All right. So I just did that. V equals IR, did Ohm's law, and I did it at the source. So the voltage supply is 9. I don't know what the current is. The resistance is 18. So therefore, I can solve for the current that's coming out of the battery, and that's 0.5 amps. So if this is 0.5 amps, then that means all of these are 0.5 amps because there is only one path. So they all have 0.5 amps. All right, there's only one flow. So now if you look, I know the resistance, I know the current, I can figure out the voltage drops at these three guys. So let's test it out now. See what you get. I'll be back in a second with the answer. All right, there they are. There's all those calculations. So there's the voltage drop at the 5, the 7, and the 6. So basically it's just plug and chug. You know the current of all for 5 or 0.5, so just multiply them by the different resistances. In this case, 0.5 is nice. Just cut those resistances in half, and then you can figure out all the voltage drops everywhere. So what that means is I can go back in here, and I always like to fill this out just to no, I don't want that color. I don't want that. That works. Is it blue? Hey, it's blue. I go back in and I just kind of fill these all out. So I have 3 volts here, and then at the 7 I've got 3.5 volts here, and over here I got 2.5 volts. So now I've solved the problem. I've answered the problem, but never finish here. I know it looks like you're done, but you want to make sure it's right, because especially if you get more complicated ones, that might take more steps, and you're prone to make mistakes. So here's what I always do whenever I solve these. I always make sure that I double check that I got the right answer. So here's my double check. I always use one of our rules to solve. So the very last thing I solved for was voltage. That's the very last thing I solved for. So I'm going to use my voltage rule to check myself. So the rule for voltage is the voltage of the source is equal to the total voltage drops. So when they're in series, at least. So I add up all my voltage drops, 2.5, 3, 3.5, 9, and yeah, it's a true statement. 9 equals 9. This is true. So therefore I have a true statement. I did double check myself. I am 100% sure this is the right answer. The beauty of doing these circuit problems is that you should walk away knowing if you got the right answer or the wrong answer. All right? So hopefully that worked out for you. If not, you can come on, see me for some more guidance, and I got more problems coming down the way. So have fun.